Hello, I just finished a large portion of the code I'm working on for my dissertation, and the task is to create a corridor that will link two unused exits between them, and do that in a procedurally method. So, so the exits can change position and rotation, and they still snap on perfectly. The other objective was to use also. I've got these corridor segments. They don't look like much, but they are prefab, so you could have beautifully looking prefabricated corridor segments to use in between. Um, so let me just go and demonstrate what we're trying to do. So we've got exit A and exit B, and we're trying to link these two together with these corridor segments. As you can see, you can only bring, because they're not, each exit is not looking at each other perfectly at a perfect angle. Uh, so we need to snap the corridor pieces to one of the two sides. And what I do after is I actually do this first part. I create a wedge out of a cube, and I place it in that kind of position, and I do the same for this side. As you can see, the wedges are different size, because obviously the angles of the room of the exits are different. So in order to create these wedges, I needed to find the angle that is here. If I just show you here, so I had to find this angle here, and I had to find this angle over here also. So how much is this angle from here? To achieve that, there's some trigonometry involved. So we know this point here, and we know this point here. We know it's we know their location, and we know their angle. So for this one, it would be exactly the way the exit is looking at. So the angle for this exit would be parallel with this line here. But we want to find where those 2 points, if we drew a line like this, where they would intersect. So we know the point, we know the angle. If we plus or minus 90 degrees, it'll give us this kind of, from this point, this kind of angle. So knowing the point and the angle, we can create an equation for this line, and create an equation for this line. Join them together, the two equations, to find the point where they intersect. And that gives us point C. So now we have point A, C, and B, and we can calculate the angles of each one. Knowing this angle here, so if we're looking for this angle, so the total here of this angle is 180 degrees. This here is 90 degrees. We know it because it's from our square corridor, which is always so that's 90 degrees. So we know this is 180, we know this is 90. Basically 90 plus this angle here that we know, plus this will equal 180 degrees. So we can find this angle, we can find this angle. And I'll show you how we use that in the program. So if let me just check this on, increase that to maybe 1.5 seconds. So I've done it in steps for this reason, for my own sanity, and to demonstrate. So first of all, you need to determine which side is the pivot point for the wedge, and it's always the side that has if you draw a line from exit A to exit B, well, but draw a line between the two exits, it'll be on the side this line is in regards to the way the exit's facing. So if this line here was over on this side, then this is the pivot point. That's how I calculate it. Obviously, that's a bit more complex. There's a situation where is the exit facing upwards or is the exit facing downwards? Like this exit, as you can imagine, this line here, 180 degrees upwards and 180 downwards. If it's facing up or down, and which is the pivot point. So, without boring you to death. What I did is I've got these adapters. So I haven't. I'm just putting this adapter here, which is basically what it does is it joins one type of exit to another. So if you're using let's say this is a square 3-meter exit, if you know that you have 3-meter corridor pieces and you have an arc exit here, you want to find the adapter that it goes from arc to the 3-meter square exit point. So as I said, I haven't done the code to search for the right piece yet. So I'm just putting I'm just placing this piece here, this adapter. So it's done the same for the other sides, and now we've got this square. This square is going to be the wedge, and I'm editing the mesh of this square to create the shape. I don't have a prefab shape. This is always going to change depending on the angles I've got. So I've got the vertices, the back right top, back left top, back left bottom, etc. So I've got the same for the front side. So what I've done is I create a game object for the vertices and put those in there. So and I create the front side, this game object in the middle of front left top and front right top, and these points become children of this front side. So when front side moves, the children move too. And if it wasn't paused, you'd see actually. Okay, no, that might mess it up. Let's see. Yeah, okay. So what it does is it takes the front side, it rotates it so it's the same angle as our exit, and then it moves front side to attach at that point of the exit, and it'll take the back side and it'll place it on the same point also. If I let this play, and then because our pivot point is on this side, I've moved the back side, unparented the points, moved the back side there, and then parented the back points to backside. So we're going to do the same for that one. So front side's going to rotate. I don't have that. Yep, it's rotated to that kind of angle, and then backside goes on top. And now I calculate these angles, as we said, with the trigonometry. It's already found point C. Oh, my mistake, sorry. Let me speed that up a bit so you can see it again. So you can see now it's created the wedge by rotating. Backside was initially here, so we rotated it the angle, the degrees we needed. So because the pivot point is here, the back left top and back right top, back left bottom did not move position, where the backside and these ones did. And then we moved the backside just to be in the middle between these 2 points, because we still need this point. And we've done the same for here. And if I just keep on playing, now it's placing the corridor parts. And I've got an adjustable corridor parts, so it'll try and fit as many parts as it can. And then I've got an adjustable part which I've also put a little torch in, and that's going to calculate what's the distance to the backside and scale the corridor correctly. So now we've got our prefab corridor, and we've got a corridor piece made by code to join 2 exits of variable distance and rotation between them. The other thing I need to do is create a wall segment for the wedge on actually both parts, because there's a slight gap here, and obviously there's a giant gap here. So I need to create again by code, similar kind of method, create by code the walls here, and obviously the ceilings, which I haven't put for demonstration purposes. And you can see it in the game. Yes. So there's no flickering between the textures there, because they're perfectly snapped together. You can see there, and we've got our lovely wall. And somewhere here is the other segments. And as I said, you could move and you could rotate. Let's see, can I do it this way? As I said, it has to be. Let me test that. And I'm just gonna set that to 0.1. That's our, well, set it to 0. It's already done in there. And again, you can see it's made a perfect fit, even though we moved. The exits were moved in rotation position between them. You can see again, it's a good fit between them. And that's it. Thanks for watching, and I'll keep you updated.